Let's look at another part of section 3, which we're going to continue solving our quadratics, but this time using the quadratic formula and completing the square. So these two methods always work, right? Something's not always factorable, and graphing can be very tedious, especially if you don't have a graphing calculator. So these will always be the go-to methods if you're having any trouble with the factoring. So quadratic formula, let's recall, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, this formula works once we're in standard form. So remember, your equation must be in standard form to figure out what a, b, and c are. All right, so let's look at an example together. Hopefully you remember how to do this though. I'll do number 2 with you. So for this problem, notice it's not in standard form. So the first thing I need to do is I need to bring over that 5p. So we'll subtract 5p, and now we are in standard form. The equation equals 0. Now I know that my a value is 3, b value is negative 5, and c value is 9. So we can pop that into the quadratic formula. X equals negative b is really positive 5, right? Negative 5, plus or minus the square root of negative 5 all squared minus 4ac. And don't forget, that entire thing is all over 2a. Always double check that you plugged in the right numbers, because if something is off, obviously the rest of it will be off. So again, negative b plus or minus b squared minus 4 times 3 times 9 all over 2 times 3. Now we will simplify. We want to clean up what's inside that radical. So we have 5 plus or minus the square root of 25 minus 4 times 3 times 9 gives me 108 all over 6. We'll keep on going. So 5 plus or minus the square root of 25 minus 108 gives me negative 83 all over 6. From here, we try to break up that square root of negative 83. Well, are there any perfect squares in 83? I don't think so, right? We can divide by 4, by 9, by 16. There's nothing. However, we have that negative inside. So as we've learned, that means we need to take out an imaginary. So we'll take out an I, and we're left with 83 inside. Therefore, I have two solutions. X equals 5 plus I root 83 over 6, and I equals 5 minus I root 83 over 6. Okay, if we can actually simplify the square root, so let's say it said the square root of 100, we would get 10, we would continue solving. 5 plus 10 over 6 and get an answer. 5 minus 10 over 6 and get an answer. So hopefully you remember that one pretty well, and I want you to give number 1 and 3 a shot. The good news is for both of those, they're already in standard form. So just identify A, B, and C and plug them into the quadratic formula. Be sure to simplify fully. Okay, now let's look at completing the square. So completing the square is also another skill that we've done in Algebra 1 and Algebra 2, but you may have forgotten a little bit of the steps, so I listed them here for you. Steps 1 and 2 can be interchangeable. It doesn't matter, but those two have to come first, which means our constant must be on the other side of the equation as everything else. Normally our quadratic term, that squared term, is on the left, so normally I bring the constant to the right-hand side. We also need to make sure the leading coefficient on that quadratic x squared term is a 1. So if it's not, we need to fix it. After that comes the actual completing the square. Completing the square means to take half of b and square it. That creates a perfect square trinomial. We can then factor and take square roots. So let me do at least one of them with you. Why don't I jump to b? B has a leading coefficient, so we have to watch for that. So if I go in order of my steps, it says to move the constant over first. Again, steps 1 and 2 can be interchangeable though. So I would add 4. Next thing we need to do is we need to make sure that leading coefficient is a 1. It's a 3, so to make it a 1, we have to divide by 3. Notice we'll get some fractions. Leave things as fractions. Do not make them as decimals. Even if it's something like 0.5, leave it as a fraction. It'll be much easier in the end. So now I have x squared minus 11 thirds x. I'm going to leave some space equals 4 thirds. So there's step 1 and 2. Constant is moved over, and the leading term is now a coefficient of 1. Here we go by taking the half of b and squaring it, completing the square. So I'm going to do that over on the side in orange. So half of my b value, remember the b value is negative 11 thirds. So 1/2 of negative 11 thirds. Notice why the fractions are easier now. So negative 11 over 6. So half of b, and then I square that. That's going to give me 121 over 36. I take that value and I add it to both sides. Okay, so we're going to add 121 over 36 to the left-hand side, and if I do that to one side, I must do it to the other. From here, we're going to clean things up. So what I just did was completing the square, so I created a perfect square trinomial. How do I factor that perfect square trinomial? Well, that left-hand side, I take the square root of the first term, square root of x is x. I take the sine of the middle term, so that's minus. And again, I take the square root of that last term I just created. So the square root of 121 over 36 is 11/6. And it becomes all squared. Okay, so again, square root of the first term, square root of the last term, and then the sine of the middle term. What's that going to equal? We'll clean up that right-hand side. So let's make this become a 36. I multiplied by 12, so this becomes a 48. I like this because 48 plus 121 gives me 169. Why do I like that number? Even though we have a fraction, my next step is, on step 5, to take the square root. Well, if I take the square root of this left-hand side, the square cancels, so I'm left with x minus 11/6. And if I take the square root of this right-hand side, I have 2 perfect squares in there. So I don't have to worry about any rationalizing. So again, the fraction is no problem because those are both perfect squares. The square root of 169 is 13, and the square root of 36 is 6. Don't forget, though, we need the plus or minus. Last but not least, step 6, we isolate that variable. So we're going to add 11/6. Always put that out front. So I'm adding 11/6. I'll have x equals positive 11/6 plus or minus 13/6. Can I actually put those together? I can. They have a common denominator. So I have 2 solutions here. One solution is 11/6 plus 13 over 6, and the other solution is 11/6 minus 13 over 6. We'll simplify those. This gives me 24 over 6, which is 4, and the second one gives me a negative 2 over 6, which is negative 1/3. So there are my 2 solutions, and we can put that in our sort of set notation. Okay, so just as a recall, remember to move our constant over to the right-hand side. Make sure our leading term is 1. If not, it's not going to be a perfect square. Now that it's 1x squared, that's a perfect square. After that, we take half of b and square it, add it to both sides, factor and simplify. Then we take the plus or minus square root and fully simplify. Now, note, this was a lot of work. So sometimes, if it doesn't say specifically solve this with completing the square, you want to be able to look at the actual trinomial or whatever the quadratic is and think about what's my fastest method. On B, factoring would actually be the fastest method. So we're going to practice our skills of quadratic formula and completing the square on these notes in our next classwork. But please know, if I just say solve this quadratic equation, you want to recognize what's the fastest method. Okay, so try A and B. Remember again to watch for the leading coefficient. If you get any negatives and radicals, remember that it's an imaginary number, and always try to simplify as far as possible. All right, lastly, what we'll take a look at is a couple of word problems. Okay, so I'm going to set up one of them with you, and I'm going to have you try two of them on your own. The last one we've done something very similar already with, so I'm going to certainly leave that one for you. And then the other one I'm going to have you try is 2, but I may help you set that up. So let's look at number 1, though. Number 1 says find 2 real numbers such that their sum is 4 and their product is negative 117. Our goal for these is not to have 2 variables, just to have 1. So let's start with just identifying the key important information. Their sum is 4 and their product is negative 117. That's really my step 1 in the 5-step plan. Step 2 is what's super important, identifying our variables. So I'm going to say x is our first number. We're looking for 2 numbers. And if their sum is 4, that means that 4 minus x is the second number. Right? If their sum is 4, the 2 numbers together equal 4, so 4 minus the first one gives me the second one. Next from there is that I need to set up an equation. So I know their product is negative 117. With that being said, the first number, x, times the second number, 4 minus x, will equal negative 117. Remember, we need to distribute and get this equation to equal 0 first. So we'll have 4x minus x squared equals negative 117. I encourage you to always have that x squared be positive. It'll make it easier. So I'm going to move everything to the right-hand side. This gives me x squared minus 4x minus 117. From here, I want you to solve. So you can solve that using any method. If it can be factored, factor it. If it can't be, then try the quadratic formula or completing the square. But finish that one and solve the 2 unknowns. Let's set up number 2 as well, and I'll let you finish solving that. So this time we have a rectangular penguin pond at Bay Park Zoo. It's 12 meters long and 8 meters wide. Okay, so this one, for step 1, I would say let's draw a picture. So for our first scenario here, we have 12 meters long and 8 meters wide. We want to double that area of the pond by increasing the length and width by the same amount. So now we're going to have this new rectangular pond where everything is doubled. The area is doubled. And so what we need to know is what was the area of the original? Well, remember, area of a rectangle is length times width. So 8 times 12 gives me 96. If I'm going to double that, that means that that new area must be 192. We're doubling the area, but we're increasing the length and width by the same amount. So if my width was 8 and I'm going to increase it, we don't know how much, so we'll call it x. But the length, we're also going to increase by that same amount, so that too will be 12 plus x. How can I come up with an equation now? Well, I'm going to use that new penguin pond. Length times width equals area. So we'll have that 8 plus x times 12 plus x equals the new area. Now, recall, for step 2, our variable x represents the amount increased. And again, my equation is coming up with the area of that new penguin pond. So you finish solving that. Distribute, get the equation equal to 0, and solve. Lastly, number 3 is our review of our position function. Remember that position function, h of t equals negative gt squared plus v naught t plus h naught. And fill in the coefficients properly given the information given.